Hi, this is Dr. Pranjali Sharma, and in this video lecture I am going to teach you Taylor series in first form and Taylor series in second form, and later we will see some examples on Taylor's first form and Taylor's second form, which is a part of differential calculus. So what is Taylor series in first form? If fx plus h can be expanded infinitely, then according to Taylor series, f of x plus h is equal to fx plus h f dash of x plus h square by factorial 2 f double dash x plus h cube by factorial 3 f triple dash x, and so on up to infinity. One thing I want to mention over here, that it is a particular case of Taylor's theorem when remainder Rn tends to 0 as n tends to infinity. So this is the Taylor's first form. Next we will see Taylor's second form. Then next we will solve some examples of Taylor's first form and Taylor's second form. So what is Taylor's second form? This form is used to expand a function fx in terms of x minus a, or we can also say that to expand f of x about a point a, where fx can be expanded infinitely. So according to the Taylor series in second form, fx is equal to f of a plus x minus a f dash of a plus x minus a whole square by factorial 2 f double dash a plus x minus a whole cube by factorial 3 f triple dash a, and so on up to infinity. One thing I want to mention over here, that if we put x is equal to 0 and h is equal to x in Taylor's first form, the series will be changed into Maclaurin series. Let's see. If we put x is equal to 0 and h is equal to x, we can see there will be fx, then f0 plus x f dash 0 plus x square by factorial 2 f double dash 0. That means the series will change into Maclaurin series. That means Maclaurin series is a particular case of Taylor's first form. In similar way, it will also a particular case of Taylor's second form. If we put a is equal to 0, means if we expand any function about point 0, the series will be of Maclaurin series. Fx is equal to f0 plus x f dash 0 and so on. So we can observe that Taylor series are more generalization or more expansion of Maclaurin series. Next we will see some examples in Taylor series in second form and Taylor series in first form. So I am starting with Taylor series in second form. So I am taking an example to show how Taylor series in second form works. I am taking an equation that expand sin x in terms of x minus pi by 2. Hence evaluate sine 91 degree. Alright, so we take fx is equal to sin x, then use Taylor's second form. We know Taylor's second form is fx is equal to fa plus x minus a f dash of a plus x minus a whole square by factorial 2 f double dash a and so on up to infinity. Here a is pi by 2. So fx is sin x, f pi by 2 will be sine of pi by 2, value of x pi by 2, that is 1. F dash x, when sine is differentiated once, it will be cos x, and further f dash pi by 2 will be cos pi by 2, that is 0. F double dash x, which is minus sin x, so f double dash pi by 2 is minus sin pi by 2, which is minus 1. F triple dash will be minus cos x, so f triple dash pi by 2 will be again a 0. F fourth x will be sin x again, so f fourth pi by 2 will be sin pi by 2, which is 1. So we have a cycle of 1 0 and minus 1 0 for this question. So we put all the values, in Taylor's series in second form, which is written in equation number 1. So we will put all the values and see what will be the series of sin x when it has been expanded about pi by 2. So fx was sin x is fa means f pi by 2 plus x minus pi by 2 f dash pi by 2 plus x minus pi by 2 whole square by factorial 2 f double dash pi by 2, since the value of a is pi by 2 in this question. So f pi by 2 was 1 plus f dash pi by 2 was 0, so it will be x minus pi by 2 into 0 plus x minus pi by 2 whole square by factorial 2 into minus 1 plus x minus pi by 2 whole cube by factorial 3 into 0 plus x minus pi by 2 whole to the power 4 by factorial 4 into plus 1 and so on up to infinity. So removing the 0 terms, the series will be x minus 1 minus x minus pi by 2 whole square by factorial 2 plus x minus pi by 2 whole to the power 4 by factorial 4 and so on up to infinity. So this is the required series of sin x when the series is expanded about the point pi by 2, which is quite different when it is expanded about the point 0. So take it as equation number 2. We still have the second part, that we have to calculate the value of sine 91 degree using Maclaurin series. So put x is equal to 91 degree in equation number 2. So sine 91 degree. 91 degree minus 90 degree, it gives us 1 degree square by factorial 2, 1 degree to the power 4 by factorial 4 minus 1 degree to the power 6 by factorial 6 and so on up to infinity. We have to change this value into a radian, since we know that pi radian is equal to 180 degree. Therefore 1 degree will be equal to pi upon 180 radian, that is 3.74 upon 180 degree, which gives us 0.0178. So put this value factorial 2 After calculating some terms, we can get its approximate value, since it has infinite number of terms that can't be calculated. So at least you calculate first 3 or 4 terms. It gives us 0.9998 approximate. Why approximate? Since the series has infinite number of terms that can't be calculated.